Hello everyone. I welcome you back to the class of econometric methods. Myself, Dr. Muhammad Imdadul Haq. I'm an associate professor in the Department of Economics of Aligarh Muslim University. In our previous class, we had a discussion on the inverse solving a simultaneous equation using the formula for inverse of matrices. Now, and before that, what we had done is we have, by the system of, we have derived the normal equations, and these two normal equations are over here. Now, in today's lecture, what we are going to do, first we are going to find the value of b1 hat and b2 hat. So, first we convert these normal equations. First we convert these normal equations into matrix format. Now see, these two terms, they are written in this format, then the another and this last one is coming over here. It comes over here. So once we have got this, we have made these two matrices which reads at b1 hat summation x, these are all in deviation format, summation x square, x1 square, b2 hat summation x1i, x2i, then down terms are b1 hat summation x1i, x2i, b2 hat summation x2 square is equal to summation x1i, xyi, and then summation x2i, yi. Now from this, what we are doing, because if we multiply, we just segregate this and make it as a separate matrix. We have seen there we are doing ax is equal to b, so that is the basic thing we are trying to make it. If we cross multiply, when we cross multiply these two matrices, we will get this matrix. The third step, what we do is we write b1 hat, b2 hat is equal to this matrix in the inverse of this matrix multiplied by this. So this is our final matrix of which we are going to find from which we are going to derive the formulas for b1 hat and b2 hat. Using matrices, we should really appreciate it, because using matrices makes our life much easier. So, finding the inverse, we need the determinant and then these two terms. So, the same thing can be written as that matrix. If you recall our discussions in the previous class, the same matrix is being written in this format, which now what we do the multiplication of these two, so we get this matrix. So finally what we have got b1 hat, b2 hat is equal to 1 divided by summation x1 square, summation x2 square minus bracket open summation x1, x2 whole square, and the next matrix is summation x2 square, summation x1, y1, then the next term minus summation x1, x2, summation x2, y1, and down the second row, the first term is summation minus summation x2, x1, summation x1, y1, then we have summation x1 square, summation x2i, yi. Now we are going to divide all this. We are going to divide this by this term. So this is the value of b1. Next, we are going to divide. What we can do, we rearrange it, we write it so that this term it comes first, and this term which is having a minus sign before it comes second. We just this makes no change. We write this term first and this term is second, divided by, upon once we have done this, we can now simply state, this is nothing but your definition, the parameters of b1 hat and b2 hat. So what we have basically done is we started with this. We started with these two normal equations in the deviation format, and then we end up in, by using the knowledge of matrices, we derive the formulas of b1 hat and b2 hat. b1 hat is equal to summation x1i yi multiplied by summation x2 square minus summation x2 yi summation multiplied by summation x1 i2 x2 divided by summation x1 square multiplied by summation x2 square minus summation x1 x2 whole square. And b2 hat, it can be read as summation x2 yi multiplied by summation x1 square minus summation x1 y1 multiplied by summation x1 x2, this divided by summation x square 1 multiplied by summation x2 square minus summation x1 x2 whole square. So now we have done with the derivations of b1 and b2. The same can be, we had here, what was the case was we started with the normal equations. We took the error term. From this equation, we did the partial differentiation with respect to b0, b1, b2. We got these three normal equations. From these three normal equations, we derived these two normal equations and we got the values of b1 and b2. The same thing can be derived using the deviation method. Let's have a quick look at it. Now see, yi can be said is equal to, small yi is equal to yi minus y bar, and x1 is equal to x1 minus x bar, small x2 is equal to capital X2 minus x bar. Now we have this equation, y hat is equal to b0 hat plus b1 hat x1 plus b2 hat x2. We divide this by n, both the sides are divided by n. So what we get? Y bar is equal to b0 hat plus b1 hat x1 plus b2 hat x2. Now we know the values of this x1 hat, y1 hat is equal to y hat minus y bar. What we can do, we can write this equation in these terms. So yi hat, small yi hat is equal to y bar, y hat minus y bar. We have the values of y hat, we have the values of y bar, and so when we do this, beta naught cancels. What is left is one step, you can add beta hat x1 minus x1 bar. So this is nothing but beta naught x1. Next time we take these two terms, beta 2 hat x2 minus beta 2 hat x2 bar. So this, we take beta 2 hat common, so what is left is x2 minus x2 bar. So we can write it in this format. Now we have EI, the error term is equal to y minus y hat. It is in the small, in the deviation form. So yi, we write yi, and yi hat we have just now derived. So this we write over here. So now we have the final equation, we write it as summation ei square is equal to, this is y minus y hat whole square, is equal to we write it in this format, is equal to summation bracket open small yi minus b1 hat small x1 minus b2 hat small x1 whole square, x2 b2 hat x2 the whole square of it. This is the equation which uh, we are basically referring to. Now we do the differentiation as we have done in our previous equations. We do the differentiation of them with respect we do the differentiation of them with respect to b1 hat and b2 hat. So upon doing differentiation, what we get, 2 summation bracket open yi minus beta 1 hat x1i minus beta 2 hat x2i multiplied by summation x1i is we equate it with 0, and the second time when we do it in terms of beta 2 hat, we get is this is we are differentiating with respect to beta 1 hat, and here we are differentiating with respect to beta 2 hat. So what we get here is 2 summation yi minus beta 1 hat x1i minus beta 2 hat x2i multiplied by the entire thing multiplied by minus 2i. This when we open up the brackets, this equation can be written in this format and this equation can be written in this format. The first equation is written in terms of summation x1i yi is equal to b1 hat summation x1 square plus b2 hat summation x1 I x2i, and the next one is summation x2i yi is all in small terms is equal to b1 hat summation x1i x2i plus b2 hat summation x2 square. These two are nothing but the same equations which we had derived earlier, and then we have gone for, after derivation of them, you have used the inverse method of the matrices, and then we have got the values of b1 hat and b2 hat. So this is just the same method. It was just for your information to know that you can derive both the things by either using the normal equations or by using the method of minimizing the